So in this module, you're going to have to write some reports, and the tool we're going to use for those is this programming or markup language called LaTeX, which all professional mathematicians use. And there's a sort of online service that allows us to use this quite easily called Overleaf. So in this video, I'm going to just show you how to do that. So on this page, you'll find some basic instructions about using Overleaf, how to use the templates, and some basic information about how LaTeX works and so on. At the bottom, you'll also find this cheat sheet, which has some of the sort of standard things that you're going to need to know. So how to do sort of different symbols that you might need, or different mathematical constructs and so on. So if you go ahead and click on this template, and you'll find templates for all of the reports I'm asking you to write, then it will open up in Overleaf for you. If you haven't already set up an account, it will ask you to set one up, or if you've got an account, it'll prompt you to log in when you click on those templates. I'm already logged in, so it just opened up for me. And the way that Overleaf is set up, your screen is divided into three. So on the left hand side here, you sort of have this file browser, so you can see all of the different files that are part of this project. On the right hand side, you'll see the rendered document. So this is like the thing you're actually sort of creating, and there's a button here to sort of download the PDF that you produce. So once you're kind of finished writing your report, that's what you'll click to get the PDF. And then the middle part where you're going to be doing your work is the editor. So changes that I make here in the editor pane will be reflected in the document on the right hand side. So unlike applications like Microsoft Word, which is what we call a WYSIWYG application, what you see is what you get, where you're basically editing directly on the page. LaTeX asks you to basically make changes to this editor here. So let's put in my name. And then if you hit this recompile button, it takes that information and translates it into a sort of final rendered document. And the disadvantage of this, obviously, is it's less direct, but the advantage that Overleaf and LaTeX give you are that you have much more control over what the document looks like. And once you get used to using this system, you're not going to want to go back to using the other things. And that's why professional mathematicians use this tool. Okay, so the way that these templates are all set up, we've got this main.tex, and basically this document sort of sets up how the rendered document is going to look. So that all of the information in here basically sets like the font size, what size is the piece of paper, all the stuff down here defines, the color scheme and the font that's used and the margins and so on. You don't have to edit any of that, and that's what all of these comments are for, basically telling you not to edit this file, other than to sort of change your name and maybe the title of the project and so on. But over here, there's this other file called projecttext.tex, and this actually has all of the stuff in it which you're going to edit. So here, for instance, you can see that I've got this \section command, and then the name of the section is introduction, and that then renders over here as this red introduction. Okay, and then text, very simply, here is an equation, renders over here as text. So far, so simple. This is where the real power of LaTeX comes in. And there's really two reasons why professional mathematicians prefer this tool to things like Microsoft Word. And the first is that LaTeX does an incredibly good job of rendering mathematics. So you can see how here I've got this equation environment. I've got a begin and end statement, and they're kind of demarked by this sort of backslash. So the environment I'm creating is an equation, and then whatever I put in here will render as mathematics. So here I've just got a fraction, but let's go ahead and make this a little bit more involved. I can put in lots of extra stuff here. So for instance, let's say I want to do an integral. That's the command for an integral, and you can see that it gives you some suggestions here, and you can sort of see what this is going to look like. Let's put some limits on my integral, make it a definite integral. So I use the limits command there, and I can do lower limit, say of 0, and then an upper limit of infinity. So that's infty, and again you can see it gives me a little preview here of what that's going to look like. Let's do x squared, and let's take out that fraction and make it a fraction of x squared over y, say with respect to x. And now if I go ahead and click recompile, you'll see that this equation over here changes, and I get this nicely rendered bit of mathematics, mathematical symbols there. Okay, so that's the first way you're going to be putting maths in. The other thing you can do is put mathematics in line. So if you want to sort of say define a particular symbol or whatever, instead of defining a whole equation environment, which puts it on its own line and gives it a little label, which I'll come to in a second, you can also just reference specific symbols or functions in line, and you do that with these dollar signs. So if I hit recompile here, you can see it says here's an equation for x, and you can see that the x here is rendered as a sort of mathematical symbol. And that's different from what we would get if we put it outside the dollar signs. So the X there just looks like text. The X here looks like a mathematical symbol. So that's how you're going to be putting the maths in there. Okay, so that's the first thing. The first reason that professional mathematicians like this is that it does such a good job with rendering mathematics. The second reason is to do with the way that LaTeX handles references, okay? And there's two types of references. References to things within your document. So you can see here, for instance, I've got a reference to a specific equation. Here I've got a reference to a specific figure. You can reference different sections and so on as well. And the second type of reference is reference to external material. So you can see at the bottom, I've got references to kind of a textbook and a Wikipedia article. And within the text, I have the sort of reference labels that are sort of appearing there. So LaTeX does a really good job of handling this, and it handles these two different types of references in a very similar way. So we assign a label to an object that we want to reference. So here, for instance, I want to reference this equation. So I give it a label. The label here is just constant equation because previously it was just a half. And then when I want to reference it, I just use this \ref, and then I put the label in there. And the reason that LaTeX is good at this is because if I now restructure this document and put in another equation, let's go ahead and add just another equation. So I can go ahead and click on the suggestion there, and it'll put the end in for me. And let's just put in something simple. I'll just put in a constant 10 there. And I'll add a label. So let's just call it the equation for the number 10. It's not really an equation, it's just a number. But now I could reference that. So again, it's ref, and it gives me some suggestions of what labels I've defined already, so I can put that in there. Now if I recompile this document, if I'd have manually just typed in equation 1 here, well, I'm going to get a new equation 1. So I would have to manually update this to equation 2, but of course LaTeX is smarter than that, and it will update all of the numbers for me. So now you can see this equation is labeled equation 2, and LaTeX works that out for me. So this is invaluable, especially if you're working with documents and restructuring them and moving things around and so on. It's really worth getting to know how to use these labels and so on. And the same thing applies to figures. So you can see here I've got a figure, and it's including this image file that I've uploaded. So you will be doing this for your reports. You'll be generating images, figures and so on, and uploading them. And you can see that it works exactly the same. I've got this label command in there, which gives it the label sumFig, and then down here in the text I can reference that as ref sum, figure sumFig, and it puts the number in for me. Okay, so that's the kind of internal referencing within a document. The second type of referencing is called in LaTeX citation or cite. So instead of typing \ref, I type \cite, and what that will do then is point to some object in the bibliography, which then will give the information for external sources, which is important. You kind of reference these external sources. So it works exactly the same. Instead of \ref, I've got \cite, and then in the curly braces, I've got the label that I've defined, and that's all defined in this bibliography.tex. And into this, then you'll just put all of the items. So this \bib item just defines some new entry into your bibliography. So I define the label, which will be used in the text, and then I put all of the bibliographic information. So for this textbook, I've got the author, the title, the publisher, and the year. For this Wikipedia article, I've got the URL, and it's important for web-based information that you give when you accessed that information, because of course that information can change. And you'll see that all renders down here in my bibliography. And if I then cite one of these things using the labels, so cite Andrew's fictional textbook, which I've done here in the text. So cite Andrew's fictional textbook. Over here in the rendered document, you can see that renders as this kind of square brackets with a number in it. And that then is pointing down to this object in the bibliography. So those are the two main reasons for using LaTeX. There are other reasons to do with sort of how you can kind of control the layout and so on. But this is the tool that professional mathematicians use, and all of your lecture notes and so on will be written using a tool like this. So it's worth getting to know how to use it, and all of the projects that you will be working on during your time at Queen's will use this tool. So you can play with this practice template. There will be other templates provided for later projects. So it's worth getting used to this, trying out different commands, making sure you can navigate and so on all of your projects. So good luck.